Hello everyone, welcome back. In this video we're going to talk about reinforcement calculation. Now we'll start with the foundation. In order to understand how we calculate bill of quantity for reinforcement, first you have to understand the type of reinforcement, to read the reinforcement drawings, then you'll be able to calculate their quantity. We'll start with the foundation. Now, unfortunately, when we have plans on a paper, we cannot see things in a 3D. Now that's why there's a lot of new programs that they will provide as a 3D those drawings for people to understand it better. So what we explain here for our project, we'll start with explain them here, then we'll link them to the drawings here. Now we have a raft foundation. It doesn't matter, any type of foundation you have it, reinforcement still will be similar. Now a civil engineer, how do we provide on a, there are the reinforcement here, is the reinforcement we have it, we'll provide them on this drawing. So on this, in the sections, you'll see those small dots, which I believe you took reinforced concrete 1, some of you taking reinforced concrete, maybe 2. So you will see some of these small reinforcement. Now I'm not going to talk about which one is for what. This is the aim for the design of reinforced concrete courses. Now what do we have here? We have some small bars, which basically you see them as those are, you'll see them like this. So there is section. In the section you only see the diameter, the circular for those, and you see some straight. So you'll see a circle and straight within the drawing, as you can see it from here, like the green one. There's circles and there's straight. Well, they will provide an information here. Now within this, the drawing I have it, since due to the language, this sign here, that you can see it from here, this question mark, consider as a phi. Phi stands for the diameter. Wherever you see this question mark, consider as phi. Forget about this y here. So wherever you see this question mark, consider as phi. Phi stands for what? For the diameter. Since we have bar, each bar they have a diameter, yes? So this is what we call them, diameter of the bar. 12, 14, 10, 16, 25, depends on the location that we're using. So each bar, it has its own size. They call them bar size or size diameter, which is, here you have it, 14, 12, whatever. So this is 1. Now, the way that we're providing reinforcement for the foundation will be the size of the size. Now this is the spacing here. Phi means you have 14 millimeter bar size using it, 20 centimeter spacing between them. Look, he puts like this, yes? This guy here, for any of those small bars here, basically there's 20 centimeter spacing between them. 20 centimeter spacing between them. Now how many of them you have it? They provided here. 87 of them, 87 you have it. Now why there is twice repeating it? You have the bottom bars, you have the top bars. That's why they will provide the top and bottom as well. Well, if you see the drawing here, this is the two bars drawn. This is the top one, this is the top one, and this is the bottom one. Now this is from the section. We can read this detail from where? From the plan as well. Like this is the plan, yes? The reinforcement will be provided here as well, this manner. This is one of the mistakes that students or like fresh engineers do, like they don't understand how to read this. We provide this on the plan, but we don't mean this on the plan. This means that the foundation like this. I need you to understand this one. When you provide this Look, this is the plan of the top view of the foundation. Yes, we are on top of the foundation, but we cannot provide those to be seen on the top. What we do, we'll provide in this manner. So this is the top reinforcement, and this is the bottom reinforcement. This is the bottom reinforcement like this. In order to see this one much clearer, this is like from the top, I cannot see, both of them will be under each other, yes? So what we do, we'll just on the top view, when we have it, it's not a computer, look, it cannot be seen. From here you cannot see the layers. So what we have to do, that's why on the plans, you'll provide it like this, one like this, and at the bottom of it, you'll provide something like this. So you'll consider that you're providing, if there is top and bottom, you'll provide it like this. Here there is only one layer, there's only one layer, but if you can see here, there is two layers. So in order to provide these two layers on the plan, these things will be shown, which you can see it here in this manner will be shown there. Well, for the other side as well, look at the length of it's been provided with this manner. This is, remember, this is on the top view. But what does it mean? It means that you're looking at the the foundation as this way. As you're looking at the foundation this way. Imagine. So this will be the top, and the other ones will be the bottom bars. The bottom bars. Remember this. Now, when we're talking about bars, we normally separate them by their location. Top, middle, bottom. We have different name for them. So we'll come back to them step by step. Here, we'll consider them as the bottom and top. The bottom and top. So it's very easy to calculate it, by the way. Nothing hard. You just need to understand the drawings. That's it. Unfortunately, some of the countries, they will not provide too much details. Now, because now the advancement in a computer, before they were just giving 5, 14, 20. Then you have to calculate the length of the reinforcement. You have to calculate the number of reinforcement, which they are not hard, and you still can do it, and you have to learn how to do it, by the way. Because you might work somewhere that they will not provide this dimension for you. So how do you find it? I'll just show you once, but I'm not going to do it because the project that I have it here, everything is given, and it's supposed to be given. If you become a designer, you have to provide this information. Says now we have advancement in the computer, those detailing will be given. But you have to always also know how to calculate these things. Now, in order to calculate the length of the reinforcement, so the top one, you have to know if there is hook or not. What does hook means? Hook is this part of the reinforcement that you're taking it up like this. They call hook. So for the top bar here, we don't have hook. Let's make this one. For the top bar here, you can see it here. It's a straight line. It is a straight line. Now, how can you calculate the length of this one? Where this 952 came from? Now, this is 960. 960, which is the size 960. Now, in reinforced concrete courses, you understand that there's supposed to be a cover. You're supposed to leave a space from the edge of the member for the reinforcement to be safe from the environment due to the corrosion and attacks. So there is a gap here. There is a gap that you leave it. So there is a gap that you have to leave it. That's, we call it cover. So the cover here, according to the standards, changes. For example, in Turkish standard, they have different cover dimension for column, for foundation, for beam, slab. American standard something, European standard something, British standard something. So when you design, you know exactly what will be the cover that you need to use it. Now cover here, it's will be used here, it's 4 centimeter. 4 centimeter from the edges cover. So 960, 4 from there, 4 from here, that's 8. You got 952, the length of the steel. Now if you have, as you can see it here, there is a hook. because the bottom ones, you see it like this. There is a hook 30 centimeter. So you have this one, still you take the cover, by the way, you took the cover, but you add 230 to it, so it will be 60. You add it to this guy, you add 60 to this one, you'll get the bottom one as well, which is 1012 centimeter. This is how you calculate. You have the length of the element, then you take the cover, you'll get the reinforcement. You have hook, you'll add hook. This is for the foundation. We have many more. I'm not going to go into detail of them. You will learn this through the courses that you're taking. It you can calculate when you understand the cover. How does it work? Now what about the spacing? The number of them, 87. Now you have the spacing 20. Yes, this will be covered in this way. Yes, you'll put at the top like this. You put it at the top. Now you're going to use the other dimension of the foundation, which is 17.5 meter, or you can say 1750 centimeter. Then you can divide this one by 20 to see how many pieces will come out. It might not come out exactly because you have to take a distance from the distance from there, but you will come close to this number there. So if you divide 1750 by 20, let's see how much does it come. You will get 87.5. So you'll get 87. If you divide this one by 20, you'll get 87.5. You'll neglect this 0.5 because you will take a spacing from that side. You can just take the 4 centimeter from each side as well. Then you will find these 87 numbers of it. In order to do, when you learn how to design reinforcement, then you will understand how to find number of them, spacing, what does it mean. For me here, that's why I'm not going to make you responsible for this detailing how to calculate number, which will be given directly on the drawings here. So here it's given, we're just going to place this into the table we have. Now the table for the reinforcement is different. So we have something like this. Sorry, let's just clean up this one. The table is a bit different than for normal bill of quantity. Why? Because we have reinforcement. In the reinforcement, what we have it here, diameter comes, because we're looking with the diameters, 14. Now the length of it, number, similar. And there is something here we have it, reinforcement bar size, the different bar size that you have it in the plan. Now let me just take this phi, that's what I said, that this diameter hits phi. I'll remove this phi here. This is millimeters, phi 10, phi 12 means phi 14. You might have different, you can change those according to the plan. Those are in millimeters. Now how do we calculate it? Very easily. Well, let's start with calculation. Now we have two directions. Remember, this reinforcement given to me, since there is two layers, so what do I have here? I have this one, exactly this. I have two reinforcement. And there is the bottom two direction, the top two direction. And we have this chair as well. We'll come back to this chair, because how do you make the top one stand? There is a chair here. You can see there's a chair. We'll talk about these chairs as well. You see there are a lot of chairs. Yes, there's reinforcement. You have to consider it into the calculation. So we'll start with the layering. So when you realize we have two directions, you have this direction here, you have the other direction. So we can call them XY direction. XY direction. In order to make it easier for checking, we'll provide bill of quantity in this way. Well, let's decide the direction and to see what do you mean by this direction, because a lot of students make mistakes here. This is one direction, this is the other direction. So you can call this one X direction, We call this one y direction, xy. Now when we talk about y direction, you're going to take the reinforcement that are perpendicular to this one, those reinforcement. Why? Because you provide, we're talking about the reinforcement that we're putting them in the y direction. We put in the y direction like this. Yes, look at the direction of I'm going is the same direction as the y. This is what we say, that we put this reinforcement. So which one are those? The one that perpendicular to the y direction. This is y direction. When we're talking about x direction, we'll put the reinforcement that are perpendicular, which the same will provide those reinforcement. Look, those are the reinforcement I'll provide in the x direction. I'm going in the x direction, yes, but the reinforcement are perpendicular to the axis. So in order to make this one clear, what we will do, we'll have two axes, x-axis, y-axis. Remember, you're taking, this is x-axis, this is y-axis. You take the things are, for y-axis, the one that perpendicular to y-axis, and for x-axis, the one perpendicular to x-axis. This is between me and you. We're going to use it for when I'm asking you calculate, for example, reinforcement in the x direction for the foundation. You know which one I mean. You know which one I mean. So perpendicular reinforcement to the axis, and we know horizontal axis will be x-axis. So when we're writing it down, how do we write? We write it in this manner. For example, x direction. Let's start with the y direction, which is a short one. Y direction. I will write top, because we already know that there is top and bottom. Top and bottom. So I'll write top. I will write y direction, bottom here. Bottom. I have top and bottom. Now the diameter, we'll just zoom in. This is what we say, top and bottom. The top, the diameter, we have it here. Remember, those are phi here, which after phi, this is 14. 14 we have it. The first one is the number 87, which we'll use them now. So we have phi 14 here. 14, the diameter, both of them. The length of them already given to us, thanks to the designer, 952,012. So we write them down here. The length of them for the top, 952. It's very easy, by the way, if you have those. If not, you struggle. Now the number of them, we have 87 of them. Look, 87 of them. I'm not going to use the spacing here. Remember, the spacing will not be used for the bill of quantity. It will be used for the practical purposes. Now we have 87. We have 87 number. Do you have similar? Now here, what the similar means, what the number means. If we had different column, let's say single footings, you still have in each single footing xy direction. Let me explain this one here. Let's say we have a single footing here, we have a single footing here. Inside here you have a lot of reinforcement. You have a lot of reinforcement at the top. Let's say you have the same number. Let's say you have 1, 2, 3, 4, 5. The same thing you have, if they are the same, by the way, if they are the same. Now when you're writing it here, you write 14, you write the length of it. You wrote, for example, you have 5 of them. For the similar, if you have similar foundation to this one, you can just simply write it here for the similar. So similar, it's for the element. Now let's imagine that you do for a city, you're calculating reinforcement. A city of residential city, which all the buildings are the same. They have the same foundation. So you can just simply, for the similar here, you can multiply it by the number of the houses, because they have the same foundation. Yes, it's rough foundation. I have it here. It's for only have one rough foundation in a house. But if you have multi houses, you can just bring the similar here. So similarity means for the similar foundation that we have it, not for the number. Number means what? How many of these bars you have it there? 87 you have it. But do you have similar element? So the similar goes for the foundation. Do you have similar foundation? If yes, or type how many foundation you have. Now here we don't have any, we just have one similar here. Now how do we calculate? Because this is 14, the answer is supposed to come in the 14 here. By the way, when we calculating reinforcement, you calculate the length of them. Later, what will you do? You will change the length to kilogram, because we need to calculate reinforcement in kilogram. So first we calculate the length of them, then we have something we call weight per unit length. Each steel bar size, they have different weight per unit length. Let's say that it's 14 millimeter. Let's say the weight of it will be, let's say 0.8 kilogram per meter length. Then when you calculate the length of it, you multiply it by that one, you'll get the total weight per diameter. This is how we calculate it in kilogram. So you will find the total length, then you have a weight per unit length, you multiply them, you'll get, for example, I calculated, found became 1590 meter I need of this, and let's say the weight of it's 0.6 kilogram per length. You just simply say this is times this one. You need 954 kilogram of this size. Remember, we do per size. Each size we need to know. For example, this is 8 millimeter. We need to know for 8 millimeter we need 952 kilogram. 54 kilogram. Total, we can say, for example, at the ends we can calculate the sum of all to see exactly what will be the total amount of reinforcement, how many tons of reinforcement we have inside the building. That's also possible. So when we're calculating, we have to make sure this is going to go for the right column here. Well, the easy way to do it, you can do it manually. This is 14, I'm going to do it for 14. But it's not recommended each time you have to do it for the other one, yes? So I'm going to show you, no one asked me how to do this one, if function. This is for Excel, you took Excel. So if function, you took it with me, you already know how does this work. We can use an if function. If this is equal to this one, then provide the information. Sorry, let's just do this. If is equal to this one, then this one times this times this. If not, we'll leave it empty. Now you might ask me about these things. Now I'll just do it to the end, and then I'll bring this one till the end of the table I have. Now nothing will appear except this is in centimeter. I can change this one to meter, 9.52, 10.12 to be meter. Those are in meter now. Like if I change this one to 10, it will appear in the 10. So wherever we have it there, 14 will appear in the 14. This is the way that we do reinforcement calculation. Now this is in the X direction, two of them. Y direction, you will do the same thing for the X direction. So I'm going to do it X direction and bottom. Now we have something here for the X direction, interesting. Why? Because the foundation we have is 17.5 meter. You need to know something. The total length of reinforcement that comes from the factory is 12 meter. So if you realize here, for the side, for this part, you realize there is something twicely the information given. One here, one here is given. And you'll see there is a gap here which is not linked. Why? Because when you have a distance more than 12, you have to provide with two-step the reinforcement. And when we're providing with two steps, there will be a distance that you need to provide that the reinforcement is supposed to come over each other. This is, we call it splice distance. Now this distance, I mean, it can be 1 meter, it can be 50 centimeters, 70 centimeters. According to the code, there's calculation for it. But practically, they put 1 meter. Some the minimum 50 centimeters they put it. Some they put 1 meter here. In order, you cannot just bring the steels to connect them like this. Yeah, there are connectors. There are those types that they use connectors. They weld them together. There's connectors. But if you don't have these connectors, there's a way that to just overlap them. They call them overlapping. Splice how much is needed. 1 meter you can provide it. But I'm not recommending just like this. There's code, there is calculation. But practically people providing in this way. So if you see here, the first part, it's 12 meter exactly. Look, how many of this we have it? 48 bar we have it. Their size is 14. Just remember 5, 14, and the length of it 12. This is one part of it, yes. But because it's finished at 12, you have to add more. So the second part of it became what? Second part of it, again it's the same number, 48 you have it, but the length of it 612. So the total for the top, remember this for the top, the total for the top 12 meter plus 6.12. So total we have 18.12 meter for the top. It's more than the length of the footing, yes, 17.5. Why? Because of the overlap that we had it there. And for the bottom, you have 12 plus this one, 12 plus 6.72. This will be the length. You have the number, you have the size, that's it. So we're gonna go back to the table. For the X direction top, the diameter 14, both of them. For the top, we calculated 18.12. This 18.12 comes from where? Repeating again. It comes from the two part of the reinforcement. This is one, which is starting from here, comes a straight bar 12, 1200 centimeter, 12 meter. Then it continues with another one, but not directly from the overlapping, which is 612, 6.12. Add them together will be 18.12. For the other one, 12 plus 6.72 will be 18.72. We have it there. The difference between them is what? The hook. You know, you have hook added to it. So the hooks, which we said that the side of the 28 centimeter hook is provided here. Then the numbers, we said both of them 48. We had it 48. We have one similarity, and directly will be calculated by itself there. Now I can do this summation at the bottom here. I just do it here. So if you have a big table, you'll do the summation for up to here, and then at the ends you'll get the summations for them. So if you have the unit, the weight per unit length, you'll get their kilograms at the end. Now remember, we have to make sure those are in meters. Like for example, so far we have that much meter, 3000 something meter for 14. This is for the foundation, reinforcement and foundation. What else we have it there? We have the chair. This is the chair we have it there, the chair. Like it's provided 20 centimeter, 35. This is for practical, for the first people to do it. But here what is given? What is given? Or if I give it, you'll give it in English. We have phi 10. So the diameter it's phi, which is 10. The length of it 140. We have 2 per meter square. So in each meter square there's 2 of them. As you could see it from the drawings here, from this picture, you'll see that a lot you have it. So they say in each meter square you'll provide 2 of them in order for it to be stable. Why we put this one? When you put pour concrete here, those not supposed to come down. The top one is supposed to stay there. So you put this chair here. So we have to calculate this chair as well. So how do we calculate the number of them? We'll come back to it. Now we have chair. I can write chair here. Chair. The diameter of it 10 millimeter. The length of it 140, which will be 1.4 meter. Now how many of them I have it? Similarity, I only have one foundation here. one foundation. Remember, this similarity is for the foundation. Then the numbers, it says that 2 per 1 meter square. So I need to know the dimension of the foundation, which is 9.6. So dimension of the foundation is 9.6 by 17.5. 17.5, we calculated before. So if you multiply these together, you will get in meters square. And since you know that in each meter square you have 2, so you multiply it by 2. I can simply calculate the total area of this. Why I'm doing here, because it's provided for us that this chair will be provided 2 in 1 meter square. So I have to know how many meters square is the foundation area. Then I can multiply it by 2. That's going to give me the number of chairs there. Because if I have 1 meter square, like this is 1 meter square, there's 2 chairs inside it. There's 2 chairs there. So first I have to know the total area, which will be the side by the length by the width, and then multiply it by 2. I can do this one directly in Excel. I can say that the area of the foundation 9.6 by 17.5. This is meters square, the area of the foundation. But how many we have it per 1 meter square? 2. So we'll be having 336 chairs used in this area. It's a lot, yes? That's why we're calculating it. So you have 470 meter, 10 millimeter. You need it just for the chairs there. Just for those to stay, the top layer to stay. Remember again, this was what? It was written that 2 per meter square. 2 per meter square. So it will be given to you like chair, this they called in Turkish, 2 per meter square. So this is how you calculate the number of it. It's for the, you may not have this one in a single footing. In a single footing you may not have this one, or you may have just 2 inside it. So you don't have this calculation like area. Why? Because for the single footing, I mean, if you have this one, sometimes they don't even put any chair. Or they may just put 1 chair or 2 chairs, one here, or maybe even 4. If it is a bit big, they might just put in the corners in order to make it stable. But for the matte foundation, because it's a big area you have, so you have to put these chairs that you have to calculate them as numbers the way that they're given there. That is enough for the foundation that we have it here. So we calculated the total reinforcement in the foundation as we had. In the next video, we'll start with the columns reinforcement.